Number 2, do I know my slope? Do I know my slope? Yes. Do I know my y-intercept? No, that's what I need to be doing. So I'm going to use the formula y equals mx plus b. I'm going to plug 4 in for my y because it is sitting in the y spot. My slope is -1. My x is -2 plus b. 4 equals 2 plus b. 2 equals b. Now I know my slope and I know my y-intercept. It's y equals -x plus 2. Number 3, I want the equation of a line that goes through the point -1, 2, and 4, 3. So there's a line. So do we know our slope? No. So what's the first thing one use? Harrison, what's the first thing we would use, buddy? Slope formula. What is that, class? M equals y sub. Very good. So I got M equals 3 minus 2 over 4 minus a -1. That gives me 1 over 5 because that's a double negative. 1 over 5. Alright. So y equals mx plus b. Now I'm going to use one of the points. Does it matter which point I use? No, you're going to get the same answer. So I'm just going to choose the one that's got both numbers positive. So that's going to be 3 equals 1/5 times 4 plus b. So I get 3 equals 4/5 plus b. Well, that's a strange one, isn't it? Now I'm going to subtract 4/5. Do you get 11/5? Somebody put that in the calculator. 11/5? You can get fractions and mixed numbers because you're already doing 11/5. Yeah, that's right. That's what I got. 11/5. Alright, so my equation is y equals 1/5 x plus 11 over 5. Now, whenever you work these problems, guys, and like you work that one and say, oh my God, oh my goodness, I got something weird, so I must have did wrong. Not necessarily. You can get answers like that and do a little enrollment, okay? But if you did get something like that, it wouldn't be bad to check your work just to make sure that you agree with it, okay? Alright, number 7. It's through the point -1, 4 and the slope's undefined. What type of line, Jesse, is undefined? Is it x equals or y equals? X equals. It's a vertical line. X equals. So all you simply do there is put x equals what? -1. X equals -1. There's no work for that. That lets you know that it's going to be x equals. If then it says slope is 0, you'd put y equals and whatever is sitting in the y. But this is x equals -1. Number 10, it says the slope is the line is passing through 1, 2, and it's parallel to y equals 3x minus 5. Nick, what is the significance? What do we use this second part for?
It's parallel, the slope is the same.
Slope is the same. That's the only thing you use that part for, is to help you determine the slope of the line that you're working with. So you need to make a note somewhere if you didn't remember. Parallel lines have the same slope. Perpendicular lines have slopes that are what? Negative reciprocals. And what I mean by negative reciprocals, you flip it and change a sign. Flip it and change a sign.
Good morning, everybody. I'm going to start things off with the pledge this morning. So if y'all want to stand for the pledge. It's just salute, pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
Thank you, Lord. Quick announcement, just a reminder, students, please check emails and remind emails for messages and further announcements. If you've not done the THS Connect,
Yeah, have y'all joined the THS Connect?
And I hope everybody has a great start to this week.
All right. Have a great day. So, parallel to this, so I know there's a point going through 1, 2, and it's parallel to this line. So first thing I need to determine is my slope. And I use this piece of information. It's parallel, so my slope is 3. Once I've determined that, I don't use that for anything else. Okay. Now I need to know my y-intercept, so I'm going to use the equation y equals mx plus b. And my y is 2, my slope is 3, my x is 1. So I got 2 equals 3 plus b, b equals negative 1. Now that I know my slope, I know my y-intercept, y equals 3x minus 1. You said, Mr. Tester, what if I did these two and forgot to put it on the equation? Put it in the equation form, then you don't get it right on the test because it says equation. All right, number 13. It says it's through negative 3, 2 and perpendicular to this right here. Now, what if this equation was not in slope-intercept form? Would you have to put it there? Yes, you would have to do that, okay? Now, it says it's perpendicular to this. What's my slope of this line right now? Negative 1/2. Remember, perpendicular. Flip it and change the sign. So I'll flip 1/2 is what? 2, and from negative it goes to what? So my slope would be 2 is what I would use. So I'm done with that. Now, y equals mx plus b. My y is 2. My slope is 2. My x is negative 3. 2 equals negative 6 plus b. That gives me 8 equals b. I know my slope, know my y-intercept, so y equals 2x plus 8. Any questions on that? Part of your homework tonight is on the same page. Go on mark 4 through 14 even. 4, 6, 8, 12, and 14. Okay. What I'm going to do next, guys, there was a lot of, the homework, I figured there might be a lot of questions, so what I did was I went ahead and worked all your homework problems out for you and made you a copy. So while I'm posting attendance, I need you to look at yours and compare yours to mine, and then I can take any questions after that. Does everybody understand? If you already got one of these from Zero Period, just tell me. You can call Peter's group. Remember to be getting those forms into Ms. Vickers. The 1 over R was the problem that caused me grief in college. I told you about that lost sleep over.
Yeah, I did
It would be great if everything in the world worked together. You know, I mean, we don't know. Yeah, everybody's getting one. We'll study first. Yeah. We went to answer Peter's. Let me get this. Some days I do this, cut down on time, working everything out on the board. Here. Does anybody sit by you home? So Mr. Lamar's on one absent. All right, let's take a look at these. The first part, remember, our learning targets that we've learned so far, solving linear equations, solve for a given variable. The first part of this homework was solve for a given variable. 31 and 32 is pretty straightforward. Are there any questions on 31 and 32?
Did you say we can correct them?
Do what now?
Did you say we can correct them?
Oh yeah, correct them, yeah. Now on 32, first thing guys, whenever you see a fraction, get rid of the fraction. That's what my thing. So our first thing I did was multiply both sides by R2. Okay? Get rid of those fractions. 33 was pretty straightforward. 34 was the monster. And let's talk about 34 for a minute. Okay, number 34. Our fractions. First thing you're going to do is get rid of those fractions. Okay? You have denominator R sub 1, R sub 2. So you got to realize, and this is what you train your mind, you say, okay, you see 3 R's, you think that's the same variable. But no, they have different subscripts. So you got R sub 1, R sub 2, that's 3 different variables, okay? So you're going to multiply through by the common denominator of R sub 1, R sub 2. When I do this, these R's cancel out, and I'm left with R sub 1 times R sub 2 times 1. And that's why I got this right here. Here, the R sub 1's cancel out. R times R sub 2 times 1 is R sub 2. These R sub 2's cancel out. R sub 1. So when I get to that step, okay, my goal is to solve for R sub 1. But we have 2 R sub 1's in the problem. And I told you last week to start thinking about that. When you have more than one and you got to get one, what strategy did we need to start thinking about? Starts with E often ends in factor. Factor. You want to factor. Because when you factor, that gets you down to that one variable, doesn't it? Okay, so I brought both of them on the same side. So that is why I brought R sub 1 over here to this side so it could be on the same side. That is when I factored out that R sub 1. When I factored out that R sub 1, I have 1 now. Now, to finish getting it by itself, I divided both sides by what I wanted to get rid of, R sub 2 minus R, and that's what I did, and that's how I got my answer. Take a moment to let that sink in. You will have one like that on your test on Friday. Does that make sense now? We good? Number 39, first thing I saw was that fraction. I'm going to get rid of it. Okay, I'm going to multiply by the common denominator 3. Multiply this side by 3. Okay, all that stuff is together. That's one term. That's why I just multiplied it by 3. If there had been plus or minuses in there, then you had to multiply the individual terms. Does that make sense? So when I multiply this by 3, it canceled that out. I'm left with pi r squared h. I want to get r by itself, so I divide both sides by pi over 8. Divide both sides by pi h. To finish getting rid of that square, I take the square root of it. So don't forget, when you take the square root of something, you got to put the plus or minus sign, okay? That's the hint for this year. If you take the square root of something, it's plus or minus. Are there any questions on that? That's some beautiful math right here. Alright, that's all factoring. I do factor in a different way as long as you get the same answers. But you got to remember, guys, when you get to factoring, you're not done. You got to set it equal to 0. I got to have 2 solutions there. Okay? So don't forget that. Sometimes you might not have 2 solutions. You might have 1 if you get the same thing in both parentheses. Did y'all do pretty good on that? Y'all good on that? I need a hand signal. Okay, we're good? Remember, when you're solving a quadratic equation, what's your first line of defense? To see if it can be what? Factored. If it can't be factored, you're forced to use the what? That's for any problem I give you quadratic, okay? Next page. 65, it could be factored. 69 could be factored. 71 was a little bit messy. But you got the quadratic formula. Did 71 give anybody trouble?
I mean, I just put it in my calculator.
Well,
I got it done.
okay. Do you want me to tell you what I prefer?
Sure.
I prefer that because I do not. That's more exact than a decimal, so don't do that on a test Friday, or you won't get full credit. All right, 77. Okay, I got to ask you a question here. In your directions on that worksheet, it said find all real solutions. Why does Mr. Hester have this, but then put that right there? It's not a real number. So you've got to pay close attention to your directions. If it had said find all solutions, that would have been my answer. But because it said find the real, there's no real solution because that gives you an I value. That's complex. So pay close attention to your directions. Does that make sense now? Okay? Yes, Con. Right here? Okay. You can reduce here because these three numbers, each of 2 can go out of it. But once you do that, you can't because you can't take anything outside of 1. Where you?
I mean, go up like 2, 6.
Oh, that should be a 3. I'm sorry. Ms. Fisher made a mistake. Correct. That should be a 3. Because you can take a 2 out of all 3 of those. 2 divided by 2 is 1. 6 divided by 2 is 3. 14 divided by 2 is 7. Thank you for catching that. Are there any questions on your homework? We good? You like that when I work them out? I don't do that every day, so don't expect that every day. That was just to save time for the day. You can keep that in your notebook as a study guide. All right. Guys, you know what we forgot to do last week? What did we forget to do? Our class picture. Our first day class picture. We take a first day, so we're taking the first of Monday. Now, if you don't want to be in the picture, I'm not going to drag you in the picture. I'm not going to beg you to be in the picture. But if you want to be in the picture, we're going to take a selfie. Are we ready? Okay. Ready? Let's get up right in here. I got it gathered here, so now ready? First day. Like I said, if you don't want to be in, you're not be in. And I'm not going to think any different of you. Derek, if you don't want to take a selfie. Where's my phone? Thank you. Okay, here we go. Now we got a bunch of them that love each other. We all family. Team what? Hester. I forgot to say this all too. Okay, my camera's not this wide. Okay, come on. Let's get in here. Come on, Harder, get right here. Tyler, come on.
All right. You're going to have to get in the chair. Okay, do you see everybody? Okay, do you see? Run inside with you, Derek. We got. Oh, I got this. She's got this camera. Okay, you gotta get your face in it, Derek.
I got my eyebrows.
Oh, you gotta get your face in it, Derek. Okay, bring it down. Derek, bring it down. Okay, right.
I'm not
in
selfie.
Come here, come back, Tyler.
Come on, I got this.
In there. It just looks like some eyes. There you go. Here we go. Yeah, that's better. Okay, thank you. That's plenty.
Good plan.
We tried it 20. I got to delete my memory. Yeah. Thank you so much.
That's a good picture. That's our Christmas card. I'm going to print that and send it to the math teachers. All right. So, I'm going to tell y'all, thank y'all for a good first week. I'm going to tell you, I'm excited about this year because y'all have buckled down and not complained one bit during this review unit. Okay, so what we're going to do today, so does everybody feel comfortable with what we learned so far? I need a hand signal. Do you feel comfortable? Okay, so Tyler, you feel comfortable? Thank you. I need double hand thumbs. Okay, here we go. Now, what we're going to do today is we're going to continue our first learning target. We're going to talk about 2 different equations today, radical and rational, and I have 35 minutes, so I feel good that we're going to get that in. All right. Turn back to these notes right here. We're still in the same lesson in your book. You're supposed to start with lesson 1.5 college tells me skip the first 4 lessons because you should already know that. You should already know this as well. But lesson 1.5, all these equations are in the same lesson. Okay. I can solve radical equation. We talked about on Friday how we knew that was a radical equation because it has a radical in it. The goal of solving radical equations is to get what, Jackson? You know that's a good answer, but that's not the best answer at the moment. To get the radical by itself. To get the radical by itself. So first thing I'm going to do is move that 2 over. Oh, that's supposed to be 8. Now, how do I get rid of that? How do I get under that radical to work with it? You square both sides. Very good. So I got 5x minus 16 equals 64. Move the 16 over. That gives me 80. X equals 16. All right. Number 19. Can you get the radicals by itself? They are kind of already are, aren't they? So these are easy. What you simply just do, square both sides. When you square both sides, the square root and the square does what? Cancel each other out. T equals 9. Are there any questions on those two? Okay. Number 20. We want to get the radical by itself. So what's the first thing I'm going to move over? 6. Very good. I'm going to move the 6 over. Now this is the cube root. So what would I do? Instead of squaring both sides, I'm going to do what? Very good. Now I'm going to ask y'all, do I have to give the cube test and the square test this year? Y'all got those memorized by now? Good. Okay, so this would be m plus 8 equals, what's 3 cubed? Thank you. Move the 8 over, that's 19. Now 21 is the hardest of the 4, so we're going to take our time for 21. You're doing it, switching the step. Move the 1 over, and then divide by the negative, and then square it. Alright, so number 21, I want to get the radical by itself. So I'm going to move that 1 over first. So that 2x minus 1 equals negative square root of 2 minus x. Now, do I like that negative in front of that radical? Is that pretty? No, so I can get rid of it by dividing both sides by what? When I divide both sides by negative 1, what happens to everything on this side? And then like Colby said, you're going to square the binomial in just a second. So the radical is by itself now. So I'm going to square this. I'm going to square this. Well, this is easy. The square root and the square cancels out, so you're left with 2 minus x. But now you run into the situation of negative 2x plus 1 times negative 2x plus 1. Why don't you foil that out for me right now? So our first step was to get the radical by itself. Then we raise both sides to the power we need it to. Sometimes you're going to have to FOIL these. once I pull that out, I got 4x squared minus 4x plus 1. Do you agree? What's your hand signal? Do you agree? Oh. What's hands? Let's go back to our hand signals. You know what? We're just going with it. I know that you agree. Do you agree? This was agreed. We're all good with that. I know that we're good. Okay. Moving on. Okay, so we're good on that. Okay. Now, equals 2 minus x. What happens when I put that in there? We have moved from a radical equation to a what? Quadratic. And quadratic has to be set equal to what? 0. So I set that equal to 0. Combine some like terms. Did y'all agree? It's 4x squared minus 3x minus 1. Did we get that? Okay. Now, I factor. You factor however you know how to factor. We're not going to. I factor it my way. I do bust them up in AC hard, whatever way you want to call it. And I got negative 1/4 and x equals 1. Now let's have a life lesson here. Did y'all get that factoring when you factored it? Okay. When you take a function and you go from one function to another function and you get more than one answer, it is imperative that you check to see if those solutions work in the original. And the reason is because you went from one type of function to another. So those two are solutions to that, but it might not be solutions to the original. So you only got to worry about that when you have two answers, okay? So right now I want you to take both of these answers and go back to the original. I'm going to go and tell you one works and one don't in this case, and that's why we have this life lesson. So you always got to check in radicals if you got more than one because you have transferred from a radical to a quadratic. Yes, those two are solutions to that quadratic, but they might not be to that original. You might have a extraneous solution.
So that only happens when you
Have two.
Yeah.
Yeah.
Have two functions, basically.
Basically when you transfer from one to another, yes. Do we know how to input fractions in our graphing calculator? Yes, sir. So you put 2 parentheses, negative 1 divided by 4. Okay, yeah. Now let's go to 1 minus 2 minus. So does negative 1/4 work? Yes. Does 1 work? No. So your only answer here would be negative 1/4. Does anybody need me to come help you with your calculator? Okay. I want you to take a moment. That's as hard as a radical gets. It shows you one of each type. And if you need help with your group, that's why you're in a group. Ask them too, as well. Okay, I need a hand signal. Are you good with solving radical equations? To the chest. I don't have everybody. Okay, thank you. Alright. Okay. The next learning target and our last one for today is these 4. Solving rational equations. When you see the word rational, what do you think of? What do you think? Okay. Think of a rational number. A rational number is any number that can be expressed in the form of A over B. So rational is basically a fraction. A rational number is any number that can be expressed in the form of a fraction. So when we have rational equations, do you see all these fractions in here? That's why they look the way they do. Rational equations have fractions in it. And just like when we have fractions in linear, and when we were solving, what's the first thing we do? Get rid of them, don't we? Okay? By multiplying through by the common what? Denominator. Let me take a moment. Let's go through this. If I had that right here, what would be my common denominator? Could I make one of these become the other? No, let's think about it. If these, okay, I want you to think of it this way. I have two things. Can you make one become the other or make it become the same thing? What could I make? What would be my common denominator here? 5x, because couldn't I multiply 5 by x to get 5x? Okay. What would be my common denominator there? 6x. How about that? 21x. You brought? Oh, I thought there's some M&Ms back there you can brought me. Okay. How about this right here? Can I multiply anything by that to get that? But then you have 5x plus 25, wouldn't you? Okay, I'm just going to follow. What did you say? I'm on multiply.
Okay, so you multiply.
Oh, you saying both of them? Yes, okay. I can't make 5 become x plus 5, can I? So my common denominator would both of them together. That's what I'm trying to get out of you. Does that make sense? There's nothing I can multiply by 5 by to get that. So your common denominator would be 5 times x plus 5. No, it would be 5. Or it could be 5x plus 25 if you went ahead and done that. How about this right here? X plus 6 and x plus 3. Can I multiply anything by this to get this? Or this to get this? So your common denominator would be both of them. Does that make sense? Okay. Some of you overthinking it. Okay, hold on. All right, on number 22, I look at my denominator. What's my denominator? Well, that's my common denominator. So I'm going to multiply everything by x plus 4. Well, these cancel out, and I'm left with 3. Minus 7 times x plus 4. These x plus 4s cancel out, I'm left with negative 4. And that's so much prettier than what I started with. Now I'm going to distribute. X equals negative 3. You did this third 9 weeks in last year in Algebra 2. Yes, huh?
Well, actually, if we did it a different way, you're going to take off points.
How did you do it, though?
I subtracted negative 4 over x plus 4 from 3 over x plus 4, and the 7 to the other side. And then I simplified it.
That's only going to work on that one given problem. So you pretty much got to do this on it because that's not going to work for any other problem. Ivy, did you have a question? Not Ivy. Okay. All right, number 23. Let's look at 23. Before you try to determine common denominator, you got to make sure everything's in factor form, okay? That's the first thing. Is 2x minus 2, can you factor something out of that? 2. Yeah, so let's just rewrite it. Now that you see everything in your denominator, what would be your complete common denominator? 2 and what? X minus 1. You will multiply everything by 2 and x minus 1, okay? So these 2's cancel out. This x minus 1 cancels out. So what's left in this whole thing right here? 3. These 2's cancel out. I'm left with 1 times x minus 1. You say, Mr. Fisher, I already know 1 times x minus 1 is x minus 1. Do I need to put that? If you can do that in your head, you're fine. The x minus 1's cancel out. What's 2 times 2? 4. That is so much prettier than what we had.
Doing the rational equations, you don't worry about, so if it's not in the denominator, originally
Just worry about the denominator. All right.
So X is 2.
I ain't finished it quite yet. So 3 equals x minus 1 equals 4. X plus 2 equals 4. X does equal 2. That's my answer. I love if you box your answers in. Or circle, or yes. Yeah. Okay, how'd you get it, huh?
I multiplied 1 over 2 by
Yeah, you could do it that way. You could do that to this one. For that particular one, you could have worked that way. All right. Number 24. Can I factor any of those denominators? Yes, this is what? A difference of what? Squares, yes. And guys, there are different ways of doing these problems, but I know that we're going to get to harder ones, and this method works for all of them, what I'm showing you right now. That's why I did do this method. Alright, so I'm going to factor this. 3 over x. I don't know why I just rewrote. That's supposed to be x plus 3, x minus 3. So I look at this particular problem, and I look at all my denominators. I got a lot going on. So what will be my complete common denominator there? X, then what? Plus x plus 3, and x what? Just those three. Not in a particular order, but they just got to have to include all three of those. So I'm going to come over here. X plus 3, x minus 3, and start canceling.
How did you, well, I see that x plus 3, x minus 3, but why is there an x down?
Because you had an x over here. Because you can't take anything times x to make it look like x plus 3, x minus 3. If you multiply anything by x, that would be 3x, and that's not the same thing as x plus 3. So you have to settle for everything. Alright, now I got 3, x plus 3, x minus 3, minus 2 times x plus 3 equals negative 12x. Alright. Now, you're intelligent enough, because you wouldn't be in this class if you wouldn't. X plus 3 and x minus 3. If you multiply that, you know what you're going to get, aren't you? What you're going to get? X squared minus what? Because that's different squares, isn't it? So I'm going to put 3, x squared minus 9, minus 2x squared, minus 6x equals negative 12x. Distribute, that's 3x squared minus 27 minus 2x squared minus 6x equals negative 12x. Now, I have went from a rational equation to a what? Quadratic. I have transformed. I'm going to get more than one answer, so would I have to check my answers on this particular problem? Yes. Alright, combine like terms. 3x squared and negative 2x squared is x squared. Boom, boom. Do I need to move that negative 12x over? I should already did that, because it needs to be set equal to 0. So x squared, negative 6x and 12x gives me a positive 6x minus 27 equals 0. If I factor that, that's going to be x plus 9, x minus 3. So x equals what? Yes, hon.
I came up with that in a lot simpler way.
Okay, how did you do it, hon?
So instead of like putting it like, I can't really explain this out loud.
try it this way and see if you get it not. Then if you do, which if you get the same answer, it's fine. But I don't know if that will work for every single one of these. But let's go with 25.
All right, now we need to check our answers. I want you to take a moment to plug in and see if it works. Well, first of all, guys, you don't have to do much. Because if you plug 3 in, one of them's going to work. If you plug 3 in, what's 3 minus 3? Do you want 0 in the denominator? So what's your answer? X equals -9. Because you do not want 0 in the denominator. 0 makes it what? Undefined. All right, number 25. Can I factor anything? Yes, I can factor this last part. So x minus 3 minus 2 over x plus 1 equals what would be my common denominator? That's what I'm going to multiply everything by. Those cancel out. Distribute. Chuck at -1. What y'all think about -1? What did I mess up at?
Because whenever you combine like terms, x and -2 is going to be -1x, and then I got -6 right there. Hold on.
Yeah, what?
Yeah, I messed up my signs.
What you get, Nick?
It'd be +6. No, you're right. It's not
Okay, so -1. I remember this problem last year now. What do you say about -1? What's wrong with -1? So what's your answer to this problem? No solution. Because if you put, so you might want to check all your possible answers on these, because if I put -1 back in there, what's -1 plus 1?
0.
Can that be an answer? So your answer is no solution. So on rational, you might want to check your answers to make sure you don't run in that situation. Okay? We finally finished the first lesson. Took us 3 days. How do you feel on rational? I need a hand signal. What we're going to do tomorrow, guys, we're going to start your test on Friday is on 1.5 and 1.6. That's all. 1.7 is what we're doing in workshop. We're going to do. You probably have a couple of checkpoints on your desk. Do those, and then we're going to start the other lesson. But 1.6 on complex numbers. You remember i's, like adding, subtracting, multiplying, dividing i's. This is the hardest lesson out of the 2 lessons, what we just did. So we're going to spend some time tomorrow making sure that we got this down, okay? Y'all good with that? Okay, your assignment tonight is page 57. On that same worksheet, I gave you 4 of these and 5 radicals. So you have 9 of these off your page. Page 57. I'm going to read the number. You need to be circling number 66, 70, 74, 79. Park here to written these down. Okay. 89, 91, 93, 95, 97. It's page 57, 66, 70, 74, 79, 89, 91, 93, 95, 97. Right now you have 4 minutes. You could be doing those on the math workshop and be done with it. So all you have to do is these when you get on.
Right up here on that. If you need a sheet of Leo Club, it's up there on the shelf.
printer? Yes. I'm using my computer right here since I've already pulled it up. Okay, just print it right here. Yes, you good? For AP stats, I have about 3 or 4, I think. Say AP stats in this class. Yes, son. Student services. You can go do that now if you would like.
You put the math problems on Google Classroom, right?
Huh?
You put those.
Yes, I need to do that right now. Thank you, Jack.